So good morning dear students. So in our last classes we discussed about some basic concept of matrix. Okay, so today we are going to discuss about how we can find out the inverse of a matrix. So at first we have to know what is inverse of a matrix. See the definition here. Let A be a square matrix of order n. So if there exists another matrix B of same order such that AB equal to BA equal to I means identity matrix, then B is called the inverse of A, and it is written as A inverse equal to B. So you have to remember one thing here. What is given? B is the inverse of A. At the same time you have to know that A is also the inverse of B. Okay, now see, if the inverse of a matrix exists, then the matrix is called invertible matrix. That means if the inverse of any matrix exists, then the matrix is called what? Invertible matrix. Now see, what is singular and non-singular matrix. A square matrix A is called a singular matrix if determinant of A equal to 0. Otherwise it is called non-singular matrix. That means if determinant of A not equal to 0, then the matrix is called non-singular matrix. Now see, the inverse of a matrix exists only in case of a non-singular matrix. Why it is? Because what is the definition of inverse of a matrix? A inverse equal to 1 by determinant of A into adjoint of A. Now if determinant of A equal to 0, then 1 by 0 does not exist. So that's why when the matrix is a singular matrix, its inverse does not exist. So inverse of a matrix exists only in case of non-singular matrix. So this is one way how we can find out the inverse of a matrix. That means it is the formula. Now we can again find out the inverse of a matrix by using elementary row and column transformation method. So basically here we are going to discuss about how we can find out the inverse of a matrix by using elementary row and column transformation. Now these are some properties of inverse of a matrix. So A inverse equal to A, and AB inverse equal to B inverse into A inverse. And always you have to remember, inverse of a matrix is unique. Now let's see how we can find out the inverse of a matrix by using elementary row and column transformation. See what step we have to follow here. The step 1 is, suppose the given matrix is A, then first we have to write the matrix in the form A into IA, where I is the identity matrix of same order as that of A. Now what is the second step? Now apply various elementary transformation. That means either it can be row transformation or it can be column operation on both left hand side and right hand side, so that left hand side reduces to I. That means left hand side becomes an identity matrix. And what is the third step? From step 2 we get new matrix equation I equal to BA. So from here what you can say, this B is the inverse of A. So we can directly write in this way, A inverse equal to B. Now let's try one example. Here see, we have to find out the inverse of this matrix, where the first row is -1 1 2, second row is 1 2 3, and the third row is 3 1 1. Now what is our step 1? At first we have to write the matrix in the form A equal to I into A. So here we write the matrix A. This is the identity matrix of same order, and this is the matrix A. Clear? So here what we are going to do here, at first we made these two elements equal to 0 by using row 1. See here, row 2 tends to row 2 plus row 1, as well as row 3 tends to row 3 plus 3 row 1. So these two elements becomes equal to 0. Now see what is our next step. Now row 1 we multiplied by minus 1, so that this minus 1 becomes equal to 1. So we got this one. See, you have to remember that same operation you have to done on the right hand side also. Clear? Now what is our next step? See here, what we are going to do here, this row 2 tends to row 2 minus row 3. So 0 minus 0, it is 0, 3 minus 4 minus 1, 5 minus 7 minus 2. Same operation we done here also. 1 minus 3 minus 2, 1 minus 0, 1, 0 minus 1 minus 1. Okay, see the next step. Next step is what? Row 1 tends to row 1 minus row 2, so that this element becomes equal to 0, and row 3 tends to row 3 plus 4 row 2. So this one, row 1 tends to row 1 minus row 2. So 1 minus 0, it is 1. Minus 1 minus minus 1, it will again 0. Minus 2 minus minus 2, it is again 0. And what is row 3? Row 3 tends to row 3 plus 4 row 2. So 0 plus 0, it is 0. Minus 4 plus 4 into minus 1, it is again 0. 7 plus 4 into minus 2, it is minus 1. Same operation we done on the right hand side also. Now see, we row 2 we multiply by minus 1. So it is become 0 into minus 1, 0. Minus 1 into minus 1, 1, minus 2 into minus 1, 2. Same operation here also we have to do. So next, row 2 tends to row 2 plus 2 row 3. So then it will becomes what? Minus 1, this one. Now what is left only? What is left only? This element we have to make to 1. So how we can make this? We multiply it by minus 1. Then it will becomes 1 0 0 0 1 0 0 0 1, and we got this matrix. Suppose this is some matrix B, then what you got? B into A equal to I, that means this one. Then what we can say? We say this B is the inverse of A, and it is written in this way, A inverse equal to this one. So this one I given a simple example of third order matrix. Here we have to find out the inverse of a matrix in a rectangle, inverse of a matrix of fourth order also. Okay, so in that case we have to use both row and column transformation. So basically in this example we use only row transformation, but here we have to use both row as well as column transformation. Okay, then that's all for today. So next class we will discuss how we can find out the rank of a matrix. Thank you.